Welcome to the Test Research and Data Symposium for Food Nutrition. Thank you for part 2 of the workshop on comparisons across RStudio and SAS software. We're so happy to bring this to you as part of the Friedman School, and we're really excited to be able to dive into this in greater depth tonight. So the way that this session will be designed is that we're going to start with about a half hour of R-related software work through, and then Stata, and then SAS, working our way from how to describe the variables you have in a data set, and working through descriptive stats, some useful code, all the way through running linear regressions. As we go, we would love for folks to be able to just use the chat as a wonderful place for discussion. We'll be monitoring it throughout the session, and we would love to try to field any of your questions as we can while we're in the thick of things, but we will also have at the end of each half hour time for a discussion. So without further ado, I'd love to introduce just briefly, or at least have everyone else introduce themselves briefly, the folks who put on this session. So I'll start with Kyle Monahan and we'll work our way around and then get started.
Hi, everyone. My name is Kyle Monahan. I'm a senior data science specialist with TTS, so we're the same people that fix your computer. I work in research technology, so I support students, staff, and faculty around research. Thank you all for coming here, and it's great to virtually meet all of you. And I forget is it Bree, maybe? Who I'm supposed to say next?
Sure. Everyone, my name's Bree Langlois. I'm a second-year PhD student in nutrition epidemiology and data science at the Friedman School. And I started out as a SAS fanatic. Now I'm a Stata fanatic and getting to become an R fanatic. So I hope you enjoy the session.
Hello, everyone. My name is Emily Sanchez. I'm also a PhD student in the nutritional epidemiology and data science. I'm in my second semester. And during my brief time here at Tufts, I've got to dip my toe into SAS and R. And so it's a pleasure just to share where I'm at in my coding journey with you all. And I hope you enjoy the session this evening.
All right. I guess I'll just steal that right from you, Ryan. I'll just introduce myself last. So my name is Kees Schipper. I am a second-year nutritional epidemiology and data science student. I really did just cut Ryan off, but I'm just going to go straight from my introduction right into R code. So like I said, I'm a second-year nutritional epidemiology and data science master's student. I program a lot in R. I'm learning Python right now. I love solving programming problems and just solving interesting problems in general. And so R gives you a very nice tool set to do so. So I'm just kind of going to start off by sharing my screen. And I'm going to pick up, can everyone see, does everyone see an R window? Everyone sees an R window. Okay, so just to pick up where I left off yesterday and also touch on a couple of things that I might have glossed over. As you can see, there's sort of this interesting color scheme. First off, so the file that we're working with, we should have shared it with you in an email ahead of time, is TNDS 2021 comparison across languages.r. There are a couple different files in the folder that should be in, but make sure it has the .r ending. This is what your script should look like, or a flavor of what it should look like. R lets you kind of customize color schemes. Sorry, I'm just setting a timer so I keep track. You can sort of customize how your window looks. Just to give an overview of the color scheme, because it's kind of important. These orangey yellow text symbolizes a function. Green text within quotes symbolizes strings or like character text. This blue text, I know there's a lot of it in here. These are just comments. So R sees all of this, but it doesn't evaluate any of it. So it's just a good way to annotate your text. And anything in red is just a numeric value. So that's sort of just a broad overview what the color scheme is and how R kind of helps you in that direction. Another thing, yesterday I kind of glossed over the set working directory function. In the script that we provided, this is a working directory that will point to where R is going to look for files. This is specific to my computer and my computer only. You're going to have to change the working directory so that it will work on your personal computer. The easiest way to do that is to go to Session, Set Working Directory, choose Directory, which will open up this file browser. I'm already kind of in the folder, but if you're in this folder that we provided you, it should have been a zip file. There should be a folder called Data. If you navigate into the Data folder and press Open, you can see in this console down here, there's this little line of output called set WD or set working directory. This will give you the working directory that corresponds to the folder that you just chose. Copy and paste it up here. And your working directory should be different from mine, but it should work on your computer. It's a little bit tricky, but just R needs this set working directory so that it knows where to look for files and where to pull files. Just quickly, these 4 lines are just installing libraries. And so libraries are just collections of functions that you could use. This is sort of just a foolproof way to do it. I would run these 4 because with R, you have to install packages on your computer. So this will check if you have the package on your computer. If you don't have the package, R will install it for you. And then it'll use this library function to activate the package so that you can use it throughout the script. Yesterday, we went over the load and read CSV functions. These just read in our data. See this workshop data.r data, which you can find in the files folder. If you go to more, go to working directory, it'll put you right in the correct folder where all of that data should be. So we've already read in our R data. Let me actually rerun all of this so that it cleans up my global environment. RM is just removing everything from the global environment. And so we've repopulated it with our data frame. And here's our data frame. It has study ID, study arm, age of a child in days, months, gender, and a bunch of other interesting variables. So yesterday we sort of went over these helper functions. Names tells you the column names of your data set, and row tells you the number of rows. And just because yesterday we had this question, I'm running the code by having my cursor on the line that I want to run, and I'm pressing run. Or you can press Control Enter or Command Enter if you're on a Mac. I'm on a Windows, so that's what I'm using. So names gives you the column names, nrow gives you the number of rows, number of columns gives you the number of columns, str gives you the structure of your data set, so it gives you some detailed information about the types of data within your data frame. Unique, like we said yesterday, and like with this reference we used yesterday, df $gender, that's just pulling the variable gender from your data frame. As you show here, you type in the name of the data frame, $, and then you can sort of just scroll through all of your variable names. You can choose one, and that just gets you the column that you want. And distinct, so unique is just giving us the unique values of gender, and distinct is giving us the number of unique values. So for the number of different ages, we have 690 different ages in days in our data set. And I'll kind of just leave these so that you can go over on your own. We did cover this yesterday. This is just saying how many of our rows in our data set have complete values for every column. And this is just specific to the column age and days. This is saying how many of our values are missing in this one column. The only difference here is that unique vowels and distinct vowels, this lapply is just applying this function and distinct to every column of our data frame. So if we look at distinct vowels, we can see the number of distinct values for each column in our data frame. And that should, oh, also this question mark, this gives you access to an R help function, an R help file, which sort of shows you in this little window down here. If you don't know how any functions work in R or how a certain function works in R, just type question mark, that function, you'll get a help file, which is generally helpful, except once you get into like more advanced functions, they're a little bit more archaic and difficult to interpret. But anyway, so we have our data. We've looked at some ways that you can sort of manage or get an idea of what's in your data frame. So one of the first things you might want to do well, not one of the first things, but after you've planned sort of an analysis or you're just exploring your data, you might want to make a new variable. The easiest way to do that in base R is to say, type out your data frame, $, and then type out the name of whatever you want your new variable to be called. So age years is not a variable that we have in our data frame yet, but we're going to make it with this operation. And this should be an arrow. And so what we're doing is saying we're taking data frame $ age days, which is a variable that we have in our data frame. We're going to divide age in days divided by 365.25, which is the number of days in a year. And we're going to store whatever value that comes out to be in this new variable df age years. And so if we look at summary df age years, we see we have whatever our age was in days, and it's divided by the number of days in a year. So now we have age in years. And so we have data on, we have children from about half a year old to about 5 years old. Another type of variable that we can make is a factor variable, which is sort of R's way of making a categorical variable. The way you would do that is you would say, so we already had this variable gender in our data set. To make it from a character, so just like a normal character variable into a factor variable, we'd use this function factor. We'd add data frame gender as the first argument. We'd specify the different levels. So just sort of give you a visual of what our data frame looks like. We have different levels of 99, 0 is the median, and 1 is the maximum. You can't really see it super well here because right now gender is a numeric variable. So we're saying our specific levels are -99, 0, and 1. And then you can apply corresponding labels to each of these values. So -99 is going to be not documented, 0 is going to be female, 1 is going to be male. We run that, and now we run summary df gender. You can see R spits out a frequency count of each label. So we have 3 not documented, this amount of female, and this amount of male. And so you can do this with a bunch of different variables. We have another variable called data frame, another variable called education level. Again, we just use factor. We specify what levels already exist in our data, and then we apply labels. So -99 is not documented, 0 is no education, 1 is some primary, and so on and so forth. So if we do a summary before, you can see in our console we have sort of this numeric range, even though it's a factor variable in reality. We run factor, and now we look at summary. And now we have, again, frequency counts of each category in our variable. So now that we've gotten a little bit of data management under our belt, we can see, look at different summary statistics individually. But I'm going to actually stop right there. There were a lot of chats. I'm wondering if any of those were questions. But I'm going to stop for like a couple seconds if there are any questions. You can either leave them in the chat or just unmute yourself. Okay, so if there are no questions, we'll go to getting statistical summaries of your data. So I've used this a couple times, as you've seen, but the easiest way to sort of get broad statistics for every variable in your entire data set is just say summary and then the name of a data frame. So our data frame is called df, so we can say summary df. And I will expand this a little bit. And so we can see we have summary statistics for study ID, study arm, age days, age months, really every variable in our data frame. If you wanted more specific summary statistics, like you didn't want to spit out an entire summary and you just want, say, like the mean of a single variable, you can use these aggregation functions that R has. So it has mean, median, standard deviation. You specify the variable that you want. So we want the age months variable from data frame. And then you have this interesting option here that says NARM equals T. What that means is we're going to remove missing values, because with these aggregation functions, if you have a missing value in a variable, it sort of doesn't break the function, but you can't calculate like a mean or a median if you have a missing value. So we're just going to remove missing values and just calculate the mean of the data that we have. And here we see that the mean age in months is 13 months, 0.254. Then we can get the median the same way, and we can get the standard deviation of that variable as well. So there's no explicit function for mode in R, but this is sort of just, as you can see here, is kind of a small demonstration that in R, if you don't have a function, or there isn't a package that has a function, which at this point is kind of rare because R has so many packages since it's open source, you can actually make your own functions. And so what this function is doing, I wouldn't worry about sort of the code so much right now. All it's doing is we're making a function, get mode. We're specifying that it's a function. It takes one argument x. And what this body does is it just calculates the mode and it returns the mode as a value. So if we use get mode df age months, we see that the mode is 6.08 months. And we can actually plot that on a histogram, which is this function right here. And I'll kind of go through a little bit more in detail. We're plotting a histogram later, but R has a couple simple plotting functions. Hist is one. All you do is you type in hist and you just put in a variable, and R will just spit out sort of a default histogram. I've customized this so that it has 100 breaks. I've customized the X limits, and you can customize where you're placing these X limits. And so we get this histogram. Another cool thing you can do in R is you can add text. So this function, you can add texts and lines. So what this function add line does is it's just going to add a vertical line where our mode is. So v equals get mode df age months. It's just telling us put a line where our mode is. And then you can also add text to customize your graphs even more. Again, this is sort of just exposure. If you don't understand that right now, this is fine. Which actually reminds me, we had this, I've published this online code, which is pretty much just the code that's in the R script. I should have shared this earlier, but I'm going to post this in the chat. So even if you don't have R downloaded, you can follow along just looking at this R script online. So back to some aggregation functions. R has a range function, which returns two values, the minimum and the maximum. It also has a minimum function and a maximum function. I'm actually going to highlight these so you guys have a better idea of what I'm running. Two other, I guess, lesser used summary statistics are skewness and kurtosis. Base R doesn't have skewness and kurtosis measurements, so you have to import this library called moments. If you don't have moments in your script, you can use this function down here called install packages moments. I'm not going to run that because I already have the moments package, but if you ever get an error message that says you don't have a package, just use install packages and install that package. So I'm going to use moments, and then we can calculate skewness of this distribution. And then we can also calculate kurtosis of the distribution. So R has a lot of these functions where you can just calculate simple summary statistics. Last one that I'm going to show you being this quantile function, where you can specify a variable that you want, and you can also specify what quantiles you want. So I want the 10th percentile, the 25th percentile, the 50th, the 75th, and the 90th percentile. If we run this, R will return just that. So for age months, the 10th percentile is 6.5 months, so on and so forth. So R makes it very easy to do very quick summaries of data. And if you get a little bit more advanced, you can even combine these summaries into tables for publications and such. R is very flexible in that way. All right, so I'm going to move into making a table. So say having a cross tabulation of two variables. So you want to see, okay, how many male children have a certain level of education, or something of that degree, or how many males have a certain level of education, maybe not always children. The easiest way to do this is to say use the table function. And so what a table function does is it takes two variables as input, data frame gender and data frame education. If you remember earlier, we actually turned these into categorical variables, so it'll make table, it'll make it very easy for table to sort of cross tabulate and give us categories. So if we run that, and we store this table into this variable, my table, and then we print out my table. Again, I got to remember to highlight. I always use Control Enter. Here we have a table that has cross tabulations of first the gender and then the education level. And so we can sort of see by different group breakdown, we can see, okay, males have 597 observations that have no education. As with most programming languages, there are a million ways to do anything. So there's another package called dplyr, which has this function called count. What it does is it essentially makes the same table, but it gives you the option to sort by highest value. And so it'll just spit out the same thing where you can see female with no education has the highest number, male with no education has the second highest number, so on and so forth. The question in the chat, the table is a built-in R function, but count is not a built-in R function. If you want to use count, dplyr is the package that you would use, but table is built into R, so you don't need to install anything to use that. So let's say you wanted to summarize tables by row or by column, where you can use this function margin table, and it's not extremely useful in this case where we just have these two very simple summaries, two very simple categories. But let's say the way margin table works is you say margin table, you specify the table, and you specify the dimension that you want to summarize across. So this is going to summarize across rows. And so as you can see, there are 1,127 total males, 1,523 total females, and 3 not documented. You can also specify across columns. And then if you're more interested in percentages instead of absolute counts, you can use this prop table function. Again, give it the table, and then you want to give it the column that you want to summarize by. So if we can see here, it gives sort of proportions. And as you can see, the proportions are based on all of the columns in a row should add up to 1. This is a little bit messy. So one thing that you can do is you can wrap round around prop table. So it'll give you a little bit of an easier read statistic. But as you can see, the highest percentage of females has no education. The highest percentage of males has no education. And these columns should all add up to 1. Again, you can specify by column too if you want. You can get column percentages, and you can see here each column should add up to exactly 1. Okay, so converting, well, if there are any questions, or if there are no questions, I'll keep going. But I would like to pause for a second because this is kind of a lot of stuff coming hard and fast.
I guess I do have a question, Kees. So could you go over the syntax for the row percentages again? What do those two numbers stand for?
Okay, yeah. So for these, I guess for margin table and prop table, so let's say you wanted to make row-wise percentages. Prop table takes an original table that we made up here. So we made this table called my table, which is this table right here. And so what prop table does is it takes a table as its first argument, my table, and then the second argument, this number is just a dimension. So I think, what is it? 1 specifies that the percentages are going to add up to 1 by column. So like the not documented column, this should all add up. The not documented row, this should all add up to 1. And so if you specify 2, that's going to do column-wise percentages. And so this wrapper, the round, is just saying, I want you to round to 3 decimal points, because if you don't do that, it gives you this table with a ridiculous amount of decimal points that's kind of hard to read. So I was just adding the round for easier readability. And so in margin table and prop table, the number that you're providing is just the dimension. So 1 is row-wise and 2 is column-wise.
Thank you.
Yep, no problem. All right, moving right along. So if we wanted to make convert continuous variables to categorical variables, one thing that you'd have to do is it's called Boolean indexing, but you're pretty much just indexing by a condition. So again, if we're making a new variable, we just specify a data frame, and we're making this new variable called HFIS cat, and it's going to be based off a variable that we already have in our data frame called HFIS score. And so I'm going to try to read this to you in plain English so that it makes a little bit of sense. So we're making this new variable df HFIS cat, and so where df HFIAS score is less than 1, so wherever that variable has values less than 1, HFIAS cat is going to have a value of 4. And so the next value is the same thing, except we're going to assign a value of 3 to HFIAS cat whenever HFIAS score is between 1 and 10. And so what this little section is doing is it's comparing across values of HFIAS score, and it's just saying if something is true or false. If something is true, this index will keep that value and assign it a 4. If the value is false, this index will discard that value, and so that value won't be altered. It's a little bit tricky. It's kind of hard to explain in like 2 minutes, but this is how you could turn, say, a continuous variable to categorical. So we did this for the range of values in HFIAS score all the way up to all the way past 14. So now we have 4 categories for HFIAS cat. And if we look at the summary statistics, you see we have a minimum value of 1, median of 2, max of 4, and a third quartile of 3. And we could turn that into a factor variable to sort of make it official. And here we see we have 870 in the lowest score, 2 in the second lowest, so on and so forth. And we had 9 NAs, which weren't really accounted for. Finally, we're going to save this new edited data frame using this function save data frame. This second piece of syntax is file equals, and all you have to do is specify the path that you want to store your data in. I'll kind of go through it here. This 2 decimal points is saying we're going to go 1 file up from our working directory. That happens whenever I mess with this. This should load up in a second. Sorry about that. I'm going to run everything to make sure it loads again. And it'll just take a second. Okay, so now I'm actually not going to show you exactly what's happening, but because I'm afraid that if I do this again, this is kind of just going to abort. But what this file path is saying, we're going to go 1 file up from our working directory, then we're going to go into the file output, which I can actually show you if I bring over my directory. So say we're in the data folder, the 2 dots is saying we're going to go 1 folder up, then we're going to go to the output folder, and then we're going to store our data as output data frame.rdata right here, and then we're also going to write a CSV, output data frame.csv. If you're working with just R, R actually compresses things into a data file that's much more efficient than a CSV, so I'd highly recommend it. Here I'm kind of just going to gloss over this because I'm low on time, but R makes it very easy to run a t-test. What we did here is we're only keeping rows where gender is male or female, just for simplicity's sake. Here, this is pretty much just using R's built-in function for a t-test. I'll let you sort of go over the syntax. Again, if you have trouble understanding what's going on, just type !t-test, or we'll pull up a help file and you can read through that. So here we have a t-test. We're comparing average length or height by gender. And so we have a mean for the female group and a mean for the male group. Say our outcome variable average length is not normal, we can use a Wilcox test or a non-parametric test. This sort of spits out similar things, a 95% confidence interval, a difference in location. We can also look at correlations with this function core. You just give 2 variables that you want to correlate across. Use equals complete obs is just saying we want to use only observations that have complete data for the 2 variables we're comparing. And method equals Pearson is just saying we're using the Pearson method. And then you can also use a non-parametric Spearman correlation. And as you can see, they're pretty similar anyway, so it doesn't make a huge difference. All right, in the last 5 minutes, I'm going to go over a linear regression a little bit more in detail. So just to start out, we're going to only keep data that has complete information on all variables, just to sort of simplify everything. You wouldn't do this when you're actually making a model because you want to try not to discard data or at least do something with it. So we have our new data frame for our model called dfmod. And so to specify a linear model, we use this function lm, which just stands for linear model. And then we have what's here, the first argument, which is a formula. And so how a formula works in R is it's sort of specified by this tilde, I believe it's called. And so on the left of the tilde, you have your outcome variable. So we're trying to predict average length, and our predictor is going to be average weight. And then we can specify the data that we're going to be using is dfmod. And so because we specified that the data we're using is dfmod, R will see these two variable names, and it'll say, okay, they supplied a data argument. So these are variables from our data frame. So you don't need to type out something like dfmod $, because R already knows that we're pulling from dfmod. So we made our linear model in proper syntax, so it should run correctly, we hope. And so we don't have any output. If we just ran the linear model, R does give you output. So you can see we have an intercept and our value for average weight. If you want sort of a neater form of that, you can use the summary function, because the summary function can actually be used, it's a method, so it can be used throughout a bunch of different things. Pretty much any model in R has a summary method. So we're going to summarize our linear model. We have sort of data on our residuals. We have our intercept, standard error with the t-statistics and a p-value. We have multiple r squared, adjusted r squared, and we have our value for average weight. So I think average weight's in kilograms. So it's something like for every, I think it's for every 1 kilogram increase in weight, there's a 5.69 increase in length, which I think is in centimeters. So we've specified our linear model. We have our output from our linear model. We can interpret our linear model. And then say we want to plot that. And this might go over everyone's head, but this is just something that you can do with models in R. We can use the predict function. What predict does is it takes data that you get, it takes a model. So we're predicting length model. And you can specify that we want a prediction interval. And the level of that prediction interval is going to be 95%. So that prediction interval is going to contain 95% of our observations. If we run that, we have a prediction interval. Don't worry about the warning message. It doesn't really matter. We can do the same. It's the exact same thing with a confidence interval. Just use predict to specify that the interval is a confidence interval and the level is 0.99. And this is a lot of text. I'll let you go over this on your own time because I have a minute left. But if we run this, you can actually plot, oh, that's not good. Dev off. That was too small. If we run all of this, it'll show up in a second. Here we go. So now we have a simple plot. On the x-axis, we have average weight. On the y-axis, we have average length. It's kind of hard to see, but this blue line is our confidence interval. We can see that they correlate so strongly that our confidence interval is very tight to our regression line. And then we have our prediction intervals. Then we have each individual observation. So if you wanted to visualize a plot, just plotting and using predict is an easy way to do that. Since I'm low on time, I'm just going to kind of gloss over multivariate models. If you know how to make a univariate model in R, you know how to make a multivariate model in R. All you do is you specify the formula, and then you add additional terms that you're trying to control for. So just add gender, education, HFIS score, mid-upper arm circumference, still specify that you have data or what data you're pulling from. You can still get a summary of all of your terms, p-values for all of your terms. And then here are just some interesting functions from these packages. VIF, variance inflation factor. If you're checking for collinearity, it's a good way to remove terms from your model. And then a cool thing is that you can plot sort of normal QQ, residuals versus fitted scale location, and residuals versus leverage. So these are just all ways of running diagnostics on your model that R sort of has built in. And finally, you have CR plots. component plus residual plots. So this lets you test, are all of your predictors linear with respect to the outcome, which we would like to have with a linear model. So I know I kind of glossed through the multivariate models, but like I said, if you know how to make a univariate model, you know how to make a multivariate model in R, it's very simple to carry over. I'm going to stop for any questions. And if there are no questions, we will move on to Stata. And again, if any of this sort of just like came too fast and went over your head, I'd highly recommend just looking at the document that I have online. You can read it in your own time. That way you don't have me talking extremely fast at you, and you can just read it and read it 3 or 4 times and sort of get a handle on it. But yeah, so again, if there are no questions, we can move on to Stata, but we can just wait a couple seconds. Okay, well, if there are no questions, and if you don't want to ask a question just to the entire group, feel free to message me privately. I'll be looking at the chat. And if you have any trouble with implementing anything in the code, I'd be happy to help you out in the chat. So thanks for coming. And I guess we'll go to Stata next.
Awesome. Thanks, Kees. So moving into Stata, and before I guess we start with Stata, I just also want to emphasize that this is more meant to be breadth rather than depth. So this is entirely designed to just give you exposure to each of the different sessions. And for that purpose, we've actually provided our website has pretty much everything that you'll need to be able to replicate any of the work we do. So if you go onto our website, sites.tufts.edu/Friedman Research Symposium/program, you'll scroll down to our session, which is here, the comparisons across R, and you'll be able to see this presentation download and the additional slides and resources to be able to do this again at your own time. Partly that leads to the book that I have behind me, All the Places You'll Go by Dr. Seuss, because coding really is about the process. It's not about the end result. And it's about working through that process on your own terms and on your own pace. And this is, again, just meant to be one of those things that kind of begins that process or continues to refine that process, but isn't meant to be an all-encompassing, here's everything and all you need to know all at once. With that, I guess you don't know who I am. So my name's Ryan Simpson. I'm a second-year PhD candidate at the Friedman School. My work is in nutrition epidemiology and data science. I work predominantly in infectious disease forecasting, and I also am the research coordinator for the Informed Lab and work quite extensively with students, both at the grad school and PhD level, to help lead different research projects. So just kind of diving straight into Stata, I think where we started yesterday, fortunately, Kyle was able to help me out with some technology issues yesterday. So thank you to Kyle and also to Bree, who was extremely monumental in helping pull all of these materials together in Stata. But we began yesterday just by kind of beginning to work through your working directory. As Kees had mentioned, working directories are a great place to be able to sync your files to in any software that you're using, specifically, on your own desktop. So this is kind of my file working directory. We showed how to kind of open and close a log file. The beauty of a log file is that here you'll have your do file, which is where you report all of your code. You then have your output file, which is where all your results come. But the problem is you don't have both of them in the same place. So the nice part about a log file is that you're able to save both the code that you write and the results that you see in one location, which is known as a log file. Why all of these different names? I'm not entirely sure. They like to make it difficult for you, but hopefully this will be a little bit easier to follow. Once we start a log file, you can then either replace it if you want to rewrite your file over top of itself, same way as you would overwrite a Word document if you were to save it with the same name. Or if you were to save something and then you wanted to append to the end of it after you kind of come back, you say you go for a walk, you come back, you want to be able to pick up where you left off, you can just add the append here and it will tally things on to the end. When I code, I like to actually take this do file, instead of going kind of back and forth, I like to just slide these two things next to each other. That way I'm able to see the code as I code and see the output as it comes. Just my personal preference, but you know, for the sake of things, I think you also see that we all like to code in slightly different ways, which is also something that's really important. Is the coding process should be something you take and make yourself, and make sure you use notes, annotations, and whatnot the way you like to. Kees likes to keep his a little bit more brief with just the headings as he goes. I like to write an entire paper in my comment section, but that's just who we are, and that's how we write and we code. So feel free to kind of add and subtract different things as you go. You'll notice that in Stata specifically, anything that's a comment is in green, anything that's kind of the name is in red, and then anything in blue is either what's called a primary command, or something that's a secondary command is something that comes after typically a comma, and we'll dive into that in a little bit more depth. So as we get started, you can either, again, you could use a Stata file if you wanted to just load a Stata file for your play, I guess, from an online database, or you can import Excel files or delimited files, which is kind of a CSV or a text file. Whenever you're importing data, you want to make sure you identify what the cell range is, so the top left corner to the bottom rightmost corner, or the row range or column range, so that the data can be pulled from the right place. Once you've imported that data, the easiest way to save it, I like to say Stata is pretty intuitive, is just save, right? So you can just save it with whatever name you want, and you can add this comma replace. The comma replace makes sure that if you, for instance, were to do some sort of a change or modification here, then you're able to save any of those changes and modifications as soon as you save it, and it will overwrite that file once again. Another really useful tool is if you're saving it maybe across multiple dates, maybe this is a project you plan to work on for say 2 years. It's also easy to just put, for example, the date underneath it, or attached to the end as kind of a suffix. And then you're able to actually take that and continue to save revised versions as you go. So one of the things we'll do now is that we're going to use this data, okay? And again, if you want to run the command, you can just highlight and then run the do up here on the top. You see that we have the output data right here that we can use to get started with. I like to start off just by describing the data. So describe in this case allows you to see all the data that you have. Specifically focuses on the data name and the variable label. But what's also really nice about this is that it gives you all the way at the top some information on the size. So it's the number of variables you have, the number of observations you have in that variable. So typically the number of rows, the number of columns, and the product of rows to columns. It also tells you the last time in which the data was updated, or the last time the data was uploaded, I guess you would say. So you can see that this data was, for example, something that was pulled for March 2nd. But also you could, for example, if you were to load in one of the NHANES data sets that we had earlier, you'll be able to see that actually was created in 2012. So a good thing to be able to just check the quality of the data you have and kind of the longevity of the data that you're working with. It's not a bad place to start just to get an idea of that. And we can show how to modify all of these names and labels as we go. Another really useful command is the browse command. So browse allows you to just see the data as a data set. Kind of Stata operates somewhat from this Excel data frame. So you're able to kind of see it as if it was an Excel document, be able to scroll through it. You'll see that when you pull this up, you can actually edit. So if you wanted to specifically edit, it'll warn you that once you make any edits, those are permanent to the data set. Or alternatively, you can see the variable list here, which is always useful to see how the variables are coded. And then if you were to click on any one variable, it will tell you some more information on things related to your entire data file, as well as to the variable itself. And in terms of types of data, we don't really dive into that too much here in Stata. In R, that obviously becomes far more pertinent when you start thinking about factors versus numeric. Usually in Stata, we have bytes, which tend to be a form of numeric. We also have numeric, which is obviously numeric. And then we have things like integer, which are numerics, but typically as a discontinuous. So it's kind of 1, 2, 3, 4. And then we have things that are strings, and strings typically mean words. The difficult part, I think, in Stata as compared to R is that you don't typically have the ability to analyze strings very well. So anything that is text is not really easily analyzed. Usually you have to replace the text with something that's a numeric equivalent so that you can then run descriptive statistics on it. Otherwise, you're stuck with just kind of getting a lot of error messages as you go. In addition to describe, another favorite command of mine is codebook. If you run codebook without any variable after it, you'll be able to just pull up all the statistics as kind of a summary or an overview of the data that you have. So if we start with something like, for example, study ID, the codebook command provides you not only the data type, which we got and described, it also provides a really useful information that's not easily gotten elsewhere, which is the number of missing observations. That's really important, especially if you're thinking about your data quality, you're thinking about how missing data and structural missingness may be affecting your regression analyses or summary statistics you might run later on in the future. It also tells you how many unique values you have in the range, so min to max. And for continuous variables, like as it's reading for study ID, or perhaps age days may be a better example of that, we can actually get the mean and the standard deviation very easily from the start. And then we can also get percentiles from the median, which is the 50th percentile, the interquartile range, which is 25th to 75th, or what would be the difference between 493.5 and 231. And we're able to kind of use this as a baseline for moving forward and thinking about how our data is ultimately the distribution of our data and how it looks. When we get to something that may be more of a binary variable or categorical variable, we can see how different frequencies are of the different variables that we have based on their values. So we can see that we have 3 observations that are at -99, which in many studies is considered missing data, and also pretty much an even split between 0s and 1s. If we were to create any sort of a value label in Stata would tell you what exactly 0 means and what exactly 1 means, right? So in this case, we have a variable called gender, but my question to you becomes, which one's male and which one's female, right? And in the absence of any labels, we're not able to tell which one is which is really one of the most important parts of adding labels to your data once you've imported it into Stata, if it's not already labeled as a data set. And similarly, when you have something that's a categorical, you can walk through the same thing as well. So speaking of generating labels and variables, the easiest way of going about it is kind of a multi-step process. So I like to always make sure I drop the variable that I intend to make first. So I have information on days, the age in days. Now I want to create a variable called age in years. The easiest way to start that is to begin by making sure that it's dropped. So now I'll get my error message, which you can see in red here. So now I can see that, okay, the variable age years hasn't been created yet. Next thing I'm going to do is generate a new variable, and I'm going to set the value to missing for all observations. Missing in Stata is typically indicated with a period. And now that I have this kind of blank data set, I can now replace that data set with the values that are of interest to me. So if I want to know the age in years, you just take the age in days and divide by 365.25. And now here we are. We can see that of the 2,653 observations I had, only 2,640 were replaced. And in seeing that, I know that I should have about 13 variables missing. 13 values or observations missing. So if I were to do codebook age years real quick, I can now see the new variable that I created, and I can see the 13 missing that I have. And then if I ever ran into any issues or I needed some more help on how exactly I was going to go about replacing the variable, I can always use the help command, which I find is extremely valuable. It gives you a breakdown of how to generate the variable, how to replace a variable. And once you learn how to read this, which I won't necessarily dive into here, you'll be able to actually see how you can actually walk through step-by-step primary commands. And as I said before, separating with a comma secondary commands are things that you can add further detail or granularity in the analysis that you're doing. Next, if we wanted to label a specific variable, again, very straightforward, just label variable. So if I want to label the variable age years as age in years, I can do so. And when I do codebook age years, now I'm able to see that I have this variable age in years. And now, for example, if I wanted to create a label for a specific observation, I have something called label drop. So again, I like to make sure that the label, same as the variable, is dropped. So I haven't defined any label prior with this name. Now that I've dropped the label, I can then define the label. And the easiest way is label define. You create a label name. So in this case, if I'm going to create a variable called, if I'm creating a label for the variable gender, then I'd like to make a label called gender_label, where values of 1 are going to be assigned the word male, values of 0 are assigned the word female, and values of -99 are assigned the value, the word missing. So once I generate this observation, I can then label values gender, so label the values for the variable gender, the label gender label. And once I've done that, now when I run codebook of gender, I'm able to see that I have missing, I have female, I have male, I have my variable gender. I haven't put any variable label to it, but now I'll be able to see this label. And no matter what command I do moving forward, I'll be able to always see this label unless I specify otherwise. And as before, we can always save our data now and rewrite it. And we can see now that it's been overwritten using the same data set name. Any questions, comments, concerns before I move on? Anything at all? Totally okay if not. Onwards and upwards we go. So one of the basic things when we start moving into summary statistics, one of the basic things that we can do is use data as a calculator, right? Nowadays you have calculators everywhere, so you can just pull it out your phone or pull out your computer. But if you're in the middle of a crunch and you're trying to get a lot of data analyzed, you can use the command display, and display will actually be able to use Stata as a calculator. And it can do simple things like 5 times 5, or more complex things like natural logs, square roots, and different things like that. One of the other really great summary statistics is, again, very intuitively summarize. When you use the command summarize, you can then provide any list of variables afterwards, and it will summarize each of those variables as if it was a continuous variable. Notice how I said continuous variable, right? So we know that HFIAS score, per Kees's previous demonstration in R, is a categorical variable. So what it's going to do then is it's going to try to calculate a mean, and it's going to calculate a standard deviation, right? So as if it's treating this as a continuous variable, then it's going to always calculate it as a mean. For example, I could do the same idea as summarize gender, even though it's a binary variable, and it's going to again calculate a mean for me. And you can see that it's including the missing values with that. So we just have to be careful. As with R, it's the same idea instead in any language really. You can run a command, but that doesn't necessarily always mean it's correct. So just be careful, making sure you keep the specific variables of interest accounted for. So one of the things we can then do is use this comma detail. So this subcommand, if we run first what we had here, where you see now the two are stacked on top of each other with just mean, standard deviation, min and max. When we offer this subcommand detail, we're now able to see additional information related to the actual distribution we have. So we can see things like skewness and kurtosis, which tell us the breadth of the distribution and the height of a distribution, as well as the variance and the standard deviation, which is measures of variability for a distribution. And then we have the mean and the number of observations. So with this information, we have a very good understanding of what our distribution looks like for our variable. And we also have an idea what the percentiles are from the lowest percentiles to the highest percentiles. When you're selecting the summary commands that you want, you can actually go into greater depth in terms of not just getting those that are listed here in detail for the summarize command, but you can also do additional detail using what's called the tab stat command. So the tab stat command, if you just run it as is, will just give you the mean, right? Not exactly super useful at the surface, but if you were to add the subcommand stat and then a list of the different output that you want. So in this case, N being count, mean being the average, SD being standard deviation, min, max, and P50 being your median. You also want to state all the missing data. This is another great way of getting missing data. Then when you run this command, you're able to actually get all the statistics that you want in row. And now say you wanted to create a nice table that you can use in a paper or in any sort of report. You can list any of the variables that are of interest to you and stack them on top of each other so that you can get this nice output table to pull together. If you then want to kind of move one step further and begin visualizing data, the easiest way to do that is using a histogram. So if we start with the histogram, it'll just create a general histogram using a computer selected number of bins. If you wanted to change the bin sign to be, say, a width of 2 days, or to use a frequency distribution instead of a density distribution, these are just kind of easy subcommands that you can add. You can also add a normal distribution curve over top, which is quite useful, especially when you reduce the frequency side. Or you can add what's called the by command, and the by command allows you to run across a different group or to analyze the age in days of the observations in the study across each of the study arms that are available, as well as maintaining that width of 2 days and putting a normal curve on top of each one. So again, there's a lot of flexibility that you have in the coding software to be able to analyze across groups and to be able to really dive into understanding your distribution. Now, I think is there something in the chat?
Yeah, there's a question that came in. Can you export those tables directly from the environment to use in a paper?
Yes, you can. So there's a couple different ways of doing that. There are specific new packages that have been created by Stata where you can export those directly. The way that I like to do it is actually a little bit more old-fashioned. So I like to actually copy all of them into using copy table, and then I'll slide over into, say, an Excel document. And I like to make sure that all of the formatting is done very pretty once I put things into a paper. And I find that it's a little bit tedious to try to do that very easily in Stata. So what I'll do is I'll just actually export it here. So if you use the copy table, you'll see that everything comes out in the exact format. Then I can go through and I can add, say, things like number or different features to be able to round if I want. Say I want those rounded to 2 decimal places. If I want these without any rounding to decimal places, I can change the names. I can change any of the formatting that I want. The important part is that you make sure you do copy table. If you use just the copy and then you try to paste something into Excel, it'll actually put it all into just the one cell. And then it breaks down all of the different formatting. So just something to be mindful of. But there are other packages. There's things like putdocs and other packages that are available in Stata that you can always install and then use for that purposes too. Okay. So moving right along, after we visualize our data, maybe we want to tab the frequency of the data. So again, the tabulate command is more useful when we have things that are maybe binary or categorical variables, where the mean may not be the best representation of the data that we have. The easiest way to do that is tabulate. So now if we tabulate gender, we're able to see the missing, the female, and the male, and we have the breakdown for their frequency, their percentage of the whole, and then also their cumulative percentage across the entire distribution. If you were to tabulate multiple variables at the same time, unlike the summarize commands, which will state them one after the other, the tabulate command will actually cross-tab them against each other. So now you can see every value of every person's or every observation's value of gender across each of their values of education. If you wanted to include the missing values, you can use this comma missing, which will provide you with I guess we don't see it here because we don't have any missing data across the two of them, but usually it would add just kind of another column with a decimal, which is indicating missing, and then you'd be able to see the frequency that are missing within any of the rows. In addition, if you don't want just the frequency, but the percentages, you can do the row percentage, the column percentage, or both the row and the column percentage, which can be used with just these subcommands row call or row call. So we're able to see across columns, across rows for the percentage, across columns for the percentage. And then we have our little key here, which tells us the top is frequency, row percentage, and now column percentage. Okay. So again, nice, easy way of being able to see the frequency of all those. Next thing we can do is move into creating variables. So if we're going to convert, yes.
Sorry
think
to
there's a
interrupt. You
question.
do have another question. Oh, thanks, Bree.
Yeah.
Go ahead.
Sure.
So
From
how do
Bo.
you check the framework for how to write the syntax in Stata? I noticed that as opposed to R, you're able to write the code without commas.
So how do you check the syntax? Is that the question?
Yes.
Okay, so the easiest way to check the syntax would be to use the help command. So I like to use the help command and then tab, for example, whatever the command is that's of interest to you. There's no, I mean, the only way to, unlike R, where you can actually see a slight small X on the side that says correct or incorrect, in Stata, you don't have that until you run the command, and then you run the command and it errors and you get frustrated, you smash your computer and then you move on. Just kidding. But the easiest way to do that is to use the help command. So if you say help tab, in this case, I know I want to use tab, but I don't know how to specify these additional subcommands. When I use the help command, I can understand whether it's a one-way tab, so just one variable, or a two-way tab. I'm looking at two variables across each other. So say I want to do the two-way. Now you can actually read through the syntax. And so it says tabulate is the command. Then you put in your first variable name, your second variable name. You can use specifiers. So you can use an if conditional statement. So imagine I only wanted to do it if, say you lived in Massachusetts. So I could do if Massachusetts is equal to 1, right? If it was a binary, you live in Massachusetts or you don't, 1, 0. Or in, so maybe I only want in persons who are aged greater than 60, for example. And then weight refers to survey weighting, which I won't dive into here, but it's kind of an additional element you can add. And then you have comma options. So if we want to add any sort of a secondary command or detail, we go to the options. So if we scroll down to options, we can see that we can add any one of these options to the command of interest. So maybe when we want to do a chi-squared test, maybe a Fisher exact test, or we can do things like column and row, or call for shirt, and we're able to get the relative frequency by column or the relative frequency by row. Or alternatively, if we put missing or just M, we can treat missing values like other values, and we can get their frequency also, right? So this sort of a help command is very useful once we know how to walk through it and understand it. Otherwise, it's somewhat confusing, but there's great resources at UCLA that provide more information on how to walk through these things. And we actually have compiled those, which I'm happy to share in a Word document, or I'm sorry, the Excel document for those once I finish presenting.
I just want to point out too, what's really helpful for me is when you do the help and then whatever command, if you scroll down to the bottom of those pages, they usually give examples. And so for me, it's usually when I see the examples that it makes a lot of sense. So if you learn better that way, if you scroll down, you'll see different examples. So yeah, so that might be helpful.
Yeah, definitely. Thank you for that, Bree. Okay, so I know I'm coming close to my time, so I'm just going to kind of walk through some of the key elements here. So we talked a lot about how to drop and generate variables. So again, if we wanted to drop or generate a categorical variable, first you drop, then you can generate. And then similarly, as was done by Kees, you can use this kind of stacked layer of replacing the values. So if I wanted the values of this new variable to be 1, if your score is greater than or equal to 14, or 2, if your score ranges from greater than or equal to 10 and less than 14, greater than or equal to 3 if it's greater than or equal to 1 and less than 10, and 4 if it's less than 1, right? So the important part about using conditional statements, make sure that your bounds are completely met. So in this case, you see I use greater than or equal to 14. Alternatively, I could have done less than or equal to 14 here, but they have different meanings, right? So depending on where you want your bound to be set and what you want to be including or excluding in each of the different rows, or I'm sorry, each of the different groups, just make sure to take care of which conditional statements you're using. Once you create that, you can then use codebook, or alternatively, you can recode variables, and you can recode variables and actually introduce the specific label that you want while you're doing the recoding. So for example, we have the variable gender. If we wanted to recode 0 to be female, 1 to be male, -99 to be missing, and generate a new variable called sex, I can do that. And in doing so, I've now created this variable, let's say codebook sex, and I can see that I just created this new variable from gender, and you can see that it'll actually let you know that it was a recode from gender. You can then do things very simply. If you wanted to run a t-test, for example, the command again is just t-test. So if I wanted to run a t-test of what the average length was of individuals in the study and do comparisons across sex, I can do it that way. I can change the confidence level that I want. So if I use the level subcommand, I can do 95, 99, whatever degree of confidence I'm interested in. You can then do the non-parametric comparison to that. So we know that for mean-based distributions, or if the mean is an appropriate representation of the distribution, we use a t-test. If the median is the better representation, then we can use a non-parametric test, which the Wilcox and Ransom test is usually a pretty good candidate. and that's just the rank sum command if you move into that direction. If you wanted to run correlations, so you have two continuous variables and you want to run correlation between X and Y, you can either use correlate, which will do a Spearman correlation, or you can do a pairwise correlation, which is also a Spearman, also a Pearson correlation, but it provides you with the observations and their significance level, whereas this is just the correlation. This will provide you with the correlation coefficient, the p-value, and the number of observations used to create that. You can then create a scatter plot very easily, which is just scatter. And now we'll see our comparison of X versus Y here. Okay. Or if we wanted to dive into more different visualization tools, we can use help two-way. And two-way will show you all the different types of plots you can make using two variables, so an X and a Y variable. So this help two-way is a fantastic command, and I recommend diving into this and playing around a little bit on your own time. And then moving into regressions. Fortunately, the command is actually quite simple for a linear regression. It's just regress. So if you wanted to do regressive length and weight in this case, very easily it's regress your Y variable, then your X variable. And you'll see that this top part is all about modeling diagnostics. So it's everything related to the number of observations, your R squared or your adjusted R square, root mean squared error. For those who are very well accustomed to the total sum of squares idea when it comes to linear regressions, you'll be able to see the MSS, RSS, and TSS up here. And then in the bottom half, you'll see everything related to the coefficients, and you'll see the actual coefficient, the standard error, t-statistic, p-value, and the 95% confidence interval. If you're going to be using two continuous variables, you can just list the variable names. Stata will assume that the variable is a continuous variable unless otherwise specified. So then you could always indicate something as a categorical variable by just using I dot. So similar to R, when you talk about factors, in Stata we consider them indicators. And so we can do I dot for I dot sex, and now you can see we have the coefficient for male with the reference group, in this case being female, which is unlisted. And then we have the ability to change the base value. So if we wanted to change the reference group, we could do IB1, which would be use the indicator variable sex, but then change the base reference group to whichever is coded with the value of 1. So we can run that again, and we can see now we've changed our base value. And if we wanted to, as Kees had shown before, we wanted to, say, run a multivariate regression, we can include multiple of these variables together. So we have the continuous and the categorical. We can then predict, and this predict will create the fitted values into a new variable for us. And then we could always, as Kees had demonstrated in his session, fit this scatter plot and fit a line through it. And there's many other two-way functions that we can use to be able to look at the confidence intervals around this, etc. And with that, the final thing to do would just be to save your data and close out your log, which will allow you to kind of keep a record of everything that you've done so far. So with that, I'm going to stop there, see if there's any more questions. And then without further ado, turn it over to Emily.
Okay, feel free to ask Ryan questions. He's like a guru expert while I start sharing my screen. You guys can see this okay? Yes. Okay, and here we go. So if you joined us yesterday, we did talk about go through the basics of SAS, but if you're just joining us today, I wanted to share that within the resources folder that Ryan went through and pointed out was on the program website. Within that folder, SAS are the codes, but also just a Word document of our codes. SAS is a pretty expensive program to have the license for. So if it's not a program your organization or department is working with now, but it's maybe a program that you aspire to learn or imagine you'll be using in the future, you'll just have a Word document of that code and you can use that to follow along as well. Okay, let me make this big here, but we're going to start off in this TNDS workshop SAS code. And as a little bit of orientation again from yesterday, off to my left, We have the explorers, which we'll be able to see our libraries. We'll be able to review our results in this pane as well. And we're going to be doing most of our coding in an editor pane, as well as reviewing our log, and then a results window will pop up as well. All right, but getting started. Yesterday, we talked about creating libraries using the keyword libname. So if I run this, just like with setting a working directory, I've established a path name to a local file on my desktop, or I'm using a virtual platform, so it's on that desktop. But I've now created a library called in, and I can verify this in two ways. First, looking at my log, in which it ran successfully, amazing, off to a good start. But if I also go to libraries, I have a library now titled in, and there will be, workshop data is already in there, which is great, but we're going to add some additional tables into this, or data sets, excuse me, into this permanent library as well. Let me just go up here. Okay. As a reminder, if you are using files that have SAS datasets that have formats saved to them, which we'll talk about formats today, it's just nice at the beginning if you can, so if I removed this asterisk for a comment, you can see it turns blue. And so this would just be an option that you put in to make sure you're pulling in the formats, so that when you read your data set, it reads with the proper formatting structure. And the formats really speak to like the label names that we've heard across languages in today's presentation. Okay, but we're going to import our data using a proc or procedure statement called proc import. So first I'm going to run this, and then I'll go through, and I got my little running man, so we remember that from yesterday. So we're running that. And when we run that, we're telling SAS to create a new SAS data set called workshop 1. It's going to be pulling in our Excel file from my designated folder or path name here. I'm telling SAS it is an Excel file, and if there was another file, a SAS data set with a similar name, replace is telling SAS to overwrite that. I'm getting my variable or header names with this get names option, and then I'm telling SAS to start reading the data at row 2. Okay, we can see that that was successfully done in our log. And if we actually now go to our work or that temporary library, we should see workshop 1, and we do. So if we open that up, just like in the other programs, you get a nice view of your data. One thing that is different, I know, between at least SAS and R, is that you cannot have this data set open and still run analyses. It will just not work. Where I like R, where I can have like my Excel open, or that view my data in R, and I can still perform my statistics. I can perform my code and not have to worry about it. But you have to make sure you're closing out of these tables before you perform your next steps. So, okay. Just a note here again, if you're importing SAS files, it's just a little bit shorter, nice and sweet. And so that's just there for you to review if that's the case when you're pulling in, getting SAS data sets or those SAS 7 BDAT files. So what we didn't get to yesterday, and so where we're starting new today, is actually describing, viewing, and editing our data. So we have workshop 1, and the nice thing you can do right away is just this proc or procedure contents. And if I look at that and I run it, you can review the log, but it's automatically going to pull open the results. So that's like another confirmation that it was done successfully. And I'm going to scroll to the top, and you can see that you have workshop 1 set in your work or that temporary library, the number of observations, variables. Your engine is the version of SAS that you're operating in. And that's really, for me, like what I'm looking at in this particular table. But you can see a lot more additional information here. And then you can see a list of your variables in alphabetical order, starting with an underscore, the type of variable. So again, we in SAS, there's numeric and character variables, the length of those variables, formats, which I've hinted at a few times, but that's listed here, and then the label. So how SAS displays that variable name. And that's just a nice summary table. So you can see the number of variables you pulled in, what are their names, how will you view them? It's a very nice, easy snapshot of your data there. So if we're going to look at unique values like we have in the other programs, we can actually use a command called proc or frequency. And I'm going to tell SAS to look in workshop 1 and then build a table for gender. I have an option here to include missing, and I personally like to do that just to have visibility on any missing data. And you can include a title here. So if we run proc of our data to look at the unique values for gender, we can see there's 3 levels. So -99, 0, and 1. And then you actually get the frequency, percent, cumulative frequency, and cumulative percent. So a little more than just, hey, how many unique levels do I have? It's starting to perform some summary, analyses for this particular variable. So a little bit more than, I guess, what you would expect with your code. And I appreciate that. SAS is anticipating my needs. So I definitely appreciate that. And that's with a categorical variable, right? But what about a numeric variable? As you can imagine, for age days, right? 365 days in a year, as we get older, just more and more days, you can imagine there might be a lot of responses or levels to this particular variable. So with continuous variables, it's nice if you include this n levels option. And what you're going to get, all right, the results here, if we go up to the top, right away, you're going to see the number of levels or unique responses that you would get for this continuous variable here. You can also see, because this is numeric and there's some that are missing, right away we have a period and that there's 13 missing values for this variable. And then you can continue to scroll down. What was it? Excuse me. 689 levels. You can go and see how many observations reported an age of 171 days. So that might just be, I don't know, interesting, or if you're really looking to pass the time, go for it. But there are better ways to summarize this data for sure. But again, we're just exploring, we're trying to describe our data. So this is one way to do that. And as we talk about missing data, what about the number of observations that are complete? I'm actually going to create a second workshop data set, and I'm going to set within it my workshop 1. So I'm creating a temporary or work data set, setting in a temporary one as well. I personally like to make new data sets anytime I'm creating variables, if I'm manipulating the data, so I can always go back and compare what I did to what I'm doing. Did it work? Did I mess up? Oh no. Okay, so now I have a nice historical record of that and a reference. So here, workshop 2, I'm going to set in workshop 1, and I'm going to create a new variable called miss_n. So this is just to tell me the number of missing. So this is something I've created or that you would have created, equals, and then this is telling SAS cmiss to count the number of arguments that are missing for each variable. And this is across character and numeric variables. So it's going to count the number of missing values or variables for each observation or row for each variable. So here I'm telling SAS of, and then this was the list of all of my variables in my data set. So from study ID all the way to my HFIAS category. So if I run that, because this is a data set, you shouldn't expect that a results pane or output table is going to show up, right? Data steps produce data sets. So here I want to confirm in my log that occurred successfully. And yep, so here data set workshop 2 has been created, and now it has 15 variables, right? Because we created that miss_n variable. And to further just to explore this, here's workshop 2 in our work library. So yay, it's working. But in order to view then that missing variable, one sort of snapshot of that is using a procedure, that proc print. Here I want to print my data set workshop 2, But because there are thousands of observations, I just want to limit that to 20 because I'm just confirming that the new variable I created is now in my data set. We did that in our log, but to actually view it, here is just 20 observations. So if I go all the way down, it cuts off at 20. But what again I'm looking for, if I scroll back up, not too far. All right, new variables that you create are always at the end of your table. So now I have this miss_n column. And again, what that cmiss option or statement's going to do is go across each of these rows or observations, and it's going to tally up if it's missing any variable. And then it would be totaled and represented in this miss_n column. So what we can do with that, and this is more just, I have a habit of doing a / missing, but we would hopefully not have missing of our miss_n column. But anyways, if we run this, we can now see the different levels of our miss_n variable. So how many observations are complete or missing 0? Over 2,600. How many observations are missing 1 variable up to 4 variables? And we can see that. So this is like, again, just to see how complete your data is. And one edit I've made in this code actually, so this will be different if you are looking at the Word document, and I'll be sure to post this updated code. But I'm just going to jump to what you can do with this miss_n column is actually then filter out, say, your complete observations. So say you only want to work with those that are complete, you could do that using a where statement here. And if we were to run it, we would get that same 2,623 observations. So it gives you some flexibility here just to look at your complete observations if you'd like. Okay. All right. But now let's look at generating labels and new variables. So we've talked about variables a little bit in creating our miss_n variable, but that syntax is going to be your new variable, whatever you want to title it, equals, and then it could be numeric, it could be character in these quotes, or it could even equal an old variable name. So I could say age days equals age days if I wanted, but then I would need to change or there would need to be a reason for that, of course, but this is just sort of the flow or syntax for that. So again, I'm going to create a new work or temporary data set called workshop 3. I'm setting in workshop 2. And here I'd like to create a new variable called age years, like we've done in the other examples. And I'm saying it equals age days divided by 365.25. If I run that, again, I'd rather check the log to make sure that was run successfully. It was, but I want to view the data too. I'm a visual person, so I always want to view the data as just a way to double check. So I'm viewing the data, only going to look at 20 observations, and I can actually limit what I'm looking at or printing by just saying age days versus age years. This is a nice way too to say, well, age years equals age days divided by 365.25. Is the math correct? Hopefully it is, right? We're paying a lot of money for SAS, but it's just a nice way if it's something like you're putting in to make sure that the calculations were executed appropriately. So we run that. And we can see age days compared to age years. So say, for example, this was, I accidentally put in an asterisk or a star and it multiplied my age days. Well, then, whoops, then I know that's, coding error, human error, and I can go back and change that. So it's just nice to always visualize your output as well. Just how we've done in the other tutorials. What if we want to, or we can create new variables, using if-then statements or these conditional processing. So within workshop 3, I'm actually just going to rescore or calibrate sort of my old HFIAS score and turn it into a new variable named HFIAS cat new. So what I'm telling SAS is if this score is less than 1, well, then the new category should equal 4. Else, if it's greater than or equal to 1, but less than 10, it should equal 3, etc. You also want to account for any missing data. So else, if it's not represented here, then you can just say period, right? You could say period, or it could be a numeric value if you wanted, but you want to make sure that you are capturing for observations that may fail to meet these if then or the conditions that you've set. So we'll run this. Again, ran successfully. But I would like to see that this new variable HFIAS cat new is in my data set. So if I scroll all the way to the right again, all the way to the right, you can see my 3 variables that I've created so far, miss_n, age, years, and now this new categorical variable is present. But I still have my old scoring, right? So we've essentially just inverted this scoring system. And now I want to get rid of that, right? Because that's really confusing. It's confusing to me right now, right? So I would like to get rid of that. And one easy way to do that is simply that you would drop that category or that variable name. So if we did that, and again, just proc print this, and then all the way over, we see that that old scoring system is gone, that old categorical system's gone, and we just are left with our new one. Okay. Any questions so far before we get into labeling? No. Okay, great. So when it comes to labeling, this is how SAS is going to display your variable names. And if you remember when we looked at proc contents, initially it was however the variable columns were set up, that was how they were going to be displayed in SAS. So say I want to change that, clean it up a little bit, maybe make it easier if I am sharing this data amongst a research group, that it's just easier to interpret. So within my data step, within my workshop 3 data set, I can use this label statement and go ahead and label. This isn't necessarily formatting, but label, recreate a label for my age years, age month, age days, and education variables. So again, I'm going to run this. And I'm going to do proc print with my label. And you can see age days, instead of being all caps and in one word, here it's age in days, age in month, education is spelt out. So you can see the difference then between labels that we, or variable names that we have labeled and those that we have not. And this is just another example. So if we run a proc frequency and we look at education, oops, here we go. Oh, this is perfect. So I ran this, but I forgot 1 semicolon, which happens a lot. So as you can see, this is why you need to check your log. It just returned black text. It didn't tell me it was successful. It didn't really tell me what was going on. But this is more of a frequent human error where the first thing I check is that, did I get my semicolon, that last semicolon, to tell SAS this is the complete step and to run it. So here I am. Now it should successfully run. Let's see, unrecognized form of run. Did I not even get the whole statement? There we go, right? 3rd time's a charm. Excellent. So what this is really just saying is initially at the top here, how that variable name was displayed was just capital EDU. Now it's just spelled out as education. So we're just strictly right now looking at our variable names. And there's an option to, oh yeah, before and after. I'm just gonna look at after, because in proc contents, we can also see then that our labels in this right-hand column have been updated for each variable. So here, age months, instead of it be reading age months, education, okay? And then you can see even for our new variables we created, we haven't really established a format for them or a label. So this is a great way when you are setting up formats and labels, again, just cross-check and make sure that it was executed properly. or at least that's my mantra. As you can see, I'm missing semicolons, sometimes missing a whole line of code to run. So it may just take some patience and a couple times to run it, but all right. So now we're going to get to formatting. Formatting occurs in two steps. First, you create, well, first formats are how now like variable levels are displayed. Okay, so how they're displayed, especially for categorical variables, this can be very, very helpful. And then there's two steps really to format. So you create the format and then you have to assign the format to whichever variable you're trying to improve that display, feature of. But there's three format types. Numeric and character are the data types we've been speaking about over the past couple days, but there's actually a date format type as well. But if we go across, just starting with the numeric here, numeric format type, the format itself then is 5.1. So if I go back to my attribute table, like you'd see best 12 period here. If it was assigned 5.1, so a length of 5 with one decimal or one number after the decimal place, you would see 5.1 listed here. Okay, so this is what we're talking about with some of these formats. But what this does, it's not necessarily, especially for rounding, it's not a rounding feature. For numeric variables, it's not a rounding feature. What it does, again, a length of 5, it includes the decimal place. And then with this format, we're saying we only want one number after the decimal point. And you can change this to 7, you can change this to 9. They could really be however long you would like your data displayed. But no, this is not a rounding feature. It in fact truncates your data. So it just cuts your data off. So it is different. So you want to be mindful of that and make sure your data is represented accurately. Now, when it comes to character formats, you'll start seeing this $sign. And then again, the length of your character. So here we have 6 and a period. So the original data would look like chicken, but the result would be chicken, right? And is that meaningful for you? It might be. I guess it just depends on what you're trying to convey. I'm not sure, but that's the truncate, another example of truncating your data there. Is that meaningful? I don't know, right? And then the last format type is date. So here we have date 9 period, and there's many types of formats when it comes to date. There really is, and you could easily just Google SAS format types, and there's a lot of pre-established format types here. But this is one where, say, the data your date was originally displayed as June space 1, 1972. The result with this format just condenses it, right? Removes that comma, puts the date first. We see the years displayed last. So you have some options here. And I've added in one comment that when SAS stores dates, times, and date lines as numbers, okay? But dates are counted in days from a 0 point of January 1st, 1960. So if you are calculating days from days between interventions, or like days, I guess that's like maybe the easiest one, but I had a starting date here and it ends here, and I want to calculate what that means in months or days, years, whatever. It's important to know that when you're using these formats, it's going to start at January 1st, 1960. So that's always one I have to go back and look up, but so it's included in here for you to reference. And I believe it is different across Stata, and I'm not as sure about R.
Yeah, I think, I don't know about R, but I think Stata, it's the same, it's known as an elapsed date. And so it's the number, so if you had a value of 1 and you formatted it as a date, I think both SAS and Stata would read it as January 2nd, 1960. So that's just, but yeah, it's known as an elapsed date and kind of tricky, but I don't think it's the same in R, but it is with SAS and Stata.
Be very careful, or just take that extra step to go, yeah, where's my elapsed date in this program before conducting your analyses or thinking about how your data is going to be displayed. But in this case, so we have our 3 format types. Here, I'm just going to display first that numeric format type for age months. I'm going to proc print my workshop 3. I'm just selecting one variable using var or variable, right, for age months. I'm now going to use format age months 5.1. All right. And now I'm going to run it. And when I do, age months was previously many, many decimal places, but it's truncated that data just to display to the tenths. But again, this is not rounded data. So it could be slightly off then if you're analyzing this data going forward. And at this point, the format that we've listed here, it's only formatted in this proc or procedure step. So I mentioned that there's 2 steps to format. So you have to create the format and then associate it. So if we ran age months again, and I've commented out the format, but if we run this again, there's all those decimal places I was talking about, okay? So how do I assign or associate that permanently? That just looks like duplicate. Oh, this is just very thorough. Like I would run it all over again versus commenting out. So don't worry about that. All right. But
Emily, if I were to round instead of truncate, how would I do that?
So in your analyses, I have an example of that later on, actually. So that's a great question. If I don't get to it, Ryan, please let me know. Absolutely, we'll get to that. So say I want to assign a not quite like a permanent format, but establish formats that could be associated with a data set, either in my work data sets or a permanent one. So I'm going to use now a procedure or proc step called format. And I'm assigning a value to a new format name called gender F. So in this case, I want to display every level of gender, so 0, 1, -99, with some sort of text in this case. So I'm calling it gender F as more of a cue like gender format, but you could name it whatever. But this is just a nice way to go, all right, this format is going to be associated with my variable gender. And I can do the same thing with education. So I have EDUF, just again to prompt me to put these 2 together, the original education variable and the format. And that those levels make sense with that variable, right? I wouldn't want to assign these levels of none, some, primary, completed primary to gender, right? That doesn't make sense. So this is just a nice way to cue you to do that, or to match them essentially.
And one thing to keep in mind is if you have, say, like a yes, no variable, and you want that, you can just create one format that's like a yes, no, and assign it to multiple different variables. And I've seen people sometimes create separate formats for the same category, and you don't have to do that. So just FYI.
Oh, very nice. So it helps if I ran this, right? And then one thing I just want to show is that now in my work, so I'm in my work library, I now have a formats folder. And if I open that up, I have the 2 formats I just created. Okay, and we'll come back to that. But I've created these formats, and then it's that next step where we have to associate them. Some additional information, if you have a character variable that you want to set a format to, there's you can look back and reference that. But here we're going to associate gender F with gender. And we do that within our work data step workshop 3, set in workshop 3, format gender, and now gender F period. So the period's very important. That's one personally I sometimes forget, right? And I run this and it says gender F doesn't exist. This period indicates that it is a format. So we're going to run this, associate it. Make sure that occurred successfully. It did. And so now when I print results, so I'm just printing observations, and we did gender. So we would expect all those numeric values to now be text. And we can see that here in this column, right? So males and females or not documented would be displayed. Okay. Okay. So getting into summary statistics, as I believe I'm getting close or like short on time. We've gone through proc frequency where you've been able to see tables, like frequency tables displayed. You can do that again. We can even look at 2 variables, and I'm formatting edu here because I haven't associated them with each other yet. So if I did that, scroll to the top. So I get two separate frequency tables, one for gender, where my levels or those, like your level options are displayed nicely because of our formats. And then the same thing with education. If I wanted to create a 2x2 table, similar to like a cross tabs, you can run this and you could do like a chi-square option here as well, where it says missing, you can type in chi-square. And this essentially is going to display to you for each level, right? So not documented gender, what was their education level? For females, what was their education levels? And you can see the frequency in this top line, the percent under that, the row percent and the column percent. So it's all presented in one table, which is really nice. It's just a very concise string of code to get you a lot of information. All right. Now, when it comes to continuous variables, instead of using proc frequency, that doesn't make too much sense. We're going to use proc univariate. And specifically, I'm going to look at age days. Run this. And you are going to get a lot of great information. So I'm just scrolling to the top so we can go through this. Okay, so for the variable age days, you can see the number of observations, mean, standard deviation, skewness, kurtosis, variance. So you get that all again with just saying proc univariate. You're also going to get some your basic statistical measures, so mean, median, mode, your range, interquartile range. Okay, and then quantiles as well. So it's all part of just one sequence of code. And then your extreme values too, right? So if you're trying to review any outliers, you can view that. And then missing. All of that lovely information just from proc univariate. You can also hone in on very specific statistics if you'd like, using proc means, in which you can get, again, very similar output, but you can specify if I'm only looking at one or two, you can do that. And for any of your variables. So that's there for your reference. And at this point, if we wanted to save our data set, we're going to do that by us putting our permanent library name. So I've assigned it as in or named it as in, and I'm going to call this permanent file just so it's very clear. And now I've set in my workshop 3 data set into this new permanent file. And if I go back to my in, you'll see permanent files here. If I actually go to my folder on my desktop, you'll see permanent files here, and it's displayed as a SAS data set, okay, just to show that whole process. But we have created formats, right, to go with workshop 3. So you actually have to save these separately using proc catalog. And then you're telling SAS where are your formats now. So they're currently in our work or that temporary library. And I want to copy them out to my permanent one. And we're going to use quit just so that this process doesn't continue to sort of slow down any other computing time. Make sure I get that semicolon. All right, run this. And in my library, you can see my format file popped up. If I were to go to my folder on my desktop, formats are saved there too. Okay. You want to make sure that you're saving your SAS file like permanently and also your formats, because if you save just the SAS file without the formats, you're going to have to rerun everything. So this is a nice way that when you open up SAS for a new session, it'll just expedite your analysis and your coding process. So make sure the two go together. And if there's like a formatting like code book even, just you need to have those all in sort of one package. It can be very, very helpful. And if you were to export workshop 3 as an Excel file, right? So I don't want to save this in SAS. I want to now share this Excel file with peers. You can do so by running proc import or export. We used import to bring it in, export to do exactly that. Okay. but I wanted to get here. So if we want to produce histograms to inspect variables, got excited with two S's there, variables, we're going to produce a histogram to represent our HFIAS score using proc SGL plot. There's a couple ways to do this. I'm going to show you SGL plot, where you're just going to get the histogram. Okay, so you can see your histograms here. But an option within proc univariate is actually to say histogram of that same variable. And at this point, you're going to get all that lovely proc univariate output along with a histogram. So it's just one string of code there, or it should be, excuse me, where your histogram might be back up here. I get disoriented sometimes in this. So if you do too, you can go over to your results and actually see for proc univariate with our histogram, it has an output for every variable. Let's look here. Maybe it's at the top. Should produce a histogram. I'll have to look at that. I'll look at that actually, because it should give you a histogram as well. But you at least, if that's the case and you're stuck, you can troubleshoot and just do a proc SGL plot. And that would be something I look at in a moment.
Emily, I think you have to specify the histogram.
Yeah.
So why are all the variables coming up under univariate in the results?
Oh, what if I didn't? I'm gonna try that. Let's see. There we go. Thank you, Bree. This is why it's great to work with other coders or people that get different levels in their coding journey, because you always learn something new. So I really appreciate that. Now we have our histogram displayed, and then our univariate analysis or results would come up specific for this variable as well. Thank you so much, Bree. All right. And then to wrap things up, you also can run t-tests. And I'm going to first create or put gender -99 as missing, just recoding that as a period so that we can just compare men and women, or two gender types versus the third. All right. And so with your t-test, you would say proc t-test. You have I've created that new workshop so that I've recoded missing gender as period. You establish an alpha level, and then you have your dependent variable as var, and so average length by gender. So using class here. And when I run that, all right, this is one. Just try to start at the top. Okay. So at the top then from our t-test, we get some summary statistics by gender or by that class. You would get your p-values here. And then just included in that one proc t-test statement, you get various histograms with kernel normal curves overlaid, box whisker plots, you get your QQ plots, right? So all your diagnostics would be included in here too. Or not diagnostics, but looking at linearity here. Okay. So all of that just for one little bit of code. Wilcox and rank sum, proc NPAR, so non-parametric one way. So that's sort of a nice, little more logical, I'd say. As well. Okay. And similar, you're going to just get a lot of information and a lot of visual representation of your data in those diagnostic tools, which are really helpful.
Yeah, some people love SAS for that reason, and some people hate SAS for that reason.
I'm working more in R and like having to produce some of those with multiple strings of code or defining the aesthetics right now. I appreciate it, but I can absolutely see that where you're like, I just want the result. You know, now you're going to have to sift through, right? You see there's a lot of information in the results column that comes out. So knowing how to navigate that, I can absolutely see that, Bree. Measures of association are here, and just like with the other programs, you would have to specify if you're using Pearson or Spearman. And then this last chunk here is about your simple and your multivariable linear regressions. So with these, you're using either proc reg or regression. You might use your proc core correlations. So you'll be using those within your regressions, and then you're going to say model average length here. Then we're looking at average weight, and then we have our confidence interval limits. So if we run this. No, I'm definitely over on time, but I hope this is helpful. Again, you're going to get all sort of your diagnostic plots, which we have now discussed can be very helpful or maybe not, but at least it's just part of one output. So you shouldn't have to be hunting or recoding to find this information. You just have to scroll to the top, which takes a while. And so we're at the bottom of our observations here. So I'm not going to scroll up 2,600 observations, but you get the gist. And then if you're doing multivariable regression, you can add as many variables as you want or coefficients into your model. Okay. And you can have options like VIF as well. So there are a lot of options that you can add to these models to fit your needs or what your questions are. But that was a long overview, longer than I intended. So I hope that was helpful. As Ryan said, we're focusing on breadth and exposure. And I heard it the other day, it's like we're going to go a mile wide and an inch deep into all of these. So I really hope that was a pleasant experience, at least on the SAS side of things. And thank you.